Welcome to the first video in a series about the automatic sFDP generation developed as part of the TEADAL project. Let's begin with a simplified view of how data sharing works in TEADAL. It starts with the FDP provider who publishes a data product called an FDP, making it available for sharing. Next, an FDP consumer discovers this FDP in the catalog and initiates a negotiation process to agree on access terms and conditions. Once an agreement is reached, an FDP developer steps in to implement a shared federated data product or sFDP that conforms to the agreement. When the sFDP is ready and users can begin accessing the data under controlled conditions. However, creating sFDPs manually can be time-consuming and requires developer expertise. Moreover, different teams may choose different technology stacks or styles, which complicates long-term operations and support. The ASG subsystem was designed to resolve this. It helps developers to generate compliant sFDPs automatically and provides a unified runtime to manage sFDP execution. The ASG subsystem consists of three key components. The ASG tool is a CLI-based generator used by the FDP developer to create sFDP projects. The ASG runtime is a reusable library embedded in each sFDP, responsible for executing endpoint logic, including fetching the data, transforming the data, and caching the data if needed. The ASG sFDP is the generated fast API application that is deployed on TEADAL platform, serving data to FDP consumers as defined in the sharing agreement. Let's see more details about these components. The ASG tool is available to FDP developers as a CLI application that can be installed and run locally on their workstations. If needed, it's also possible to package and deploy the ASG tool on TEADAL nodes as developer-facing service. FDP developer invokes the ASG tool, providing the required inputs based on data sharing agreement. ASG tool then generates the sFDP in form of a Python project that includes the app itself, its documentation, and everything else required to install and operate the application locally. In addition, the project contains Docker file for creating a deployable sFDP image and a GitLab CI script for generating this image and pushing it to the TEADAL image registry. When the sFDP project is created, developers can validate it is functioning according to the requirements. Then, they can decide to push the project to the GitLab repo, which will trigger image creation and publishing. In some cases, developers can decide to create the image locally and promote it for deployment, possibly first in the staging environment. In some organizations or industries, additional validation steps and approvals might be required. Eventually, after all these approvals and validations, the new sFDP image, along with its Kubernetes manifests, policy files, is promoted to be deployed on TEADAL. The ASG runtime library is loaded and initialized at sFDP application startup. The library then powers the generated sFDP execution logic, implementing the asynchronous HTTPX-based data fetching client, 2 layers of caching, data encoding, and data transformation logic applied to every data endpoint defined for the sFDP. In addition, ASG runtime supports several service endpoints for reporting runtime statistics and telemetry for better observability and operational efficiency. Finally, the ASG sFDP is the resulting data product generated by the ASG tool validated by the FDP provider team, deployed on TEADAL, and powered by the ASG runtime library. Upon successful startup, the service can be accessed by its users, serving the origin FDP data according to the data sharing agreement. The ASG system relies on several supporting components. Some are required at sFDP generation time, some others at runtime of the generated sFDPs. At sFDP generation time, the ASG tool depends on Gene library for generating the data fetching and transformation plan for every sFDP endpoint. Gene library in turn depends on LLM inference endpoint equipped with the compliant model. To avoid reliance on external services, TEADAL node was extended to provide a local OLAMA service to be used for sFDP generation. The ASG runtime interacts with source FDPs to fetch the data and optionally with the caching services, for example, Redis. Shared across both the generation and the execution phases is the transforms library, a simple but essential module that contains reusable data transformation functions. At generation time, the ASG tool accesses the declarations and the descriptions of the transform methods. At execution time, the ASG runtime identifies transforms by their names listed in the generated execution plans and then loads and executes the transform methods implementations. This diagram summarizes the ASG subsystem, its key actors, its components, and the supporting dependencies involved. With ASG, TEADAL gains a structured yet flexible path from data sharing agreements to working data services, turning data sharing contracts into real, deployable infrastructure. It simplifies the creation of compliant data products. It ensures uniformity and traceability across sFDPs. It reduces development time and prevents inconsistencies. It lays the groundwork for automation and AI-assisted tooling. And it reinforces TEADAL's ability to manage data sharing agreements effectively. This concludes the ASG subsystem overview. Thank you for watching and see you in the next videos where we plan to zoom into specific details with hands-on demonstrations of individual components and tasks. Thank you again and stay tuned.